This is another example of a linear inequality in one variable. This linear inequality happens to contain fractions. Just as we do with equations, we're going to multiply both sides of the inequality by a quantity that will cancel the denominators, so that we will free our inequality of fractions. In this case, that multiplier I would use would be 10. If we multiplied the fractions that are there by 10, that number, that multiplier, is large enough to cancel the denominators that are there, and thus eliminating the fractions for us. Now, remember, in this situation, there are two terms on each side, so we'll need to distribute this multiplication of 10 times both of those terms. So here, let's put our think clouds above each of those terms. Here's our think cloud. We're going to think that we're multiplying both of those terms by 10. Likewise, over here, I'm thinking, this is what I'm thinking, I'm multiplying both of those terms by 10. Now, when I do the multiplication here, 10 times 3x over 10, the 10s are going to cancel, just leaving us 3x. There's no canceling here because this is a whole number being multiplied by the 10. So it's going to be plus 10. And even if it wasn't a whole number, there'd be no canceling since we have 1. We'd still have 10. Here we're going to cancel. 5 goes into 10 2 times. 2 times 1 is 2. Here, when we cancel, the 10s cancel to 1. 1 times x is x. And we've eliminated the fractions in the same way that we would eliminate fractions in an equation. Here we have a linear inequality in one variable. Now, the variables on both sides, I only want the variable in one term. So I will add 1x, since that's really what that is, minus 1x. I'll add 1x to both sides. So I have 4x plus 10 is greater than 2. And now I want to isolate the variable term, so I would subtract 10 from both sides. So 4x is greater than or equal to negative 8. Dividing both sides by 4, x is greater than or equal to negative 2. I didn't have to reverse my inequality. Even though my answer is negative, I didn't have to reverse the inequality because I divided by positive 4. It doesn't have anything to do with whether the answer is negative or positive. It has to do with whether you divided by a negative or not. And since I divided by a positive to get that answer, I didn't have to reverse the inequality sign. Don't get that confused. Students sometimes get that confused that if they get a negative answer, they have to reverse the inequality sign. No, it's only if you divided by the negative that you have to reverse the inequality sign. And the other case is if you multiply by a negative, which happens much less frequently than ever having to divide by a negative. So here's our solution set. If you pick x values greater than or equal to negative 2, then this expression, when you substitute for x, will be greater than or equal to this expression when you substitute for x.